let's try to solve another Leetcode problem. 110 balanced binary tree. So for this problem, we first need to check if this binary tree is balanced or not. So the height balanced is defined as if it is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. So for the first example, it is a balanced binary tree because for this node 3, at the left side the depth is 1, at the right side the depth is 2, so the difference is 1. But for this example, at the left side the depth is 3, at the right side the depth is 1, so the difference is 3 minus 1 is 2. So it is not balanced. That is why it's a false. So if there's no node inside of the tree, it is going to always be a true. We can solve this problem easily. We just need to use a traversal of the tree. We can use a pre-order traversal, and for each traversal of the tree, definitely we are checking all the nodes. So for example, if we are traversing this tree, for the root node, we are checking this node. Yeah. And for this node, we should know what is the depth of the left tree. It is 1. What is the depth of the right subtree? It is 2. So the difference is 1. So it means it is still okay. But if the depth is 3 here, 3 minus 1, it is more than 2. So it's going to be a false. So this is the basic idea. This means the time complexity is going to be O(n) squared. We traverse each node of the tree. At each node, we need to check the depth. Yeah. So we're going to return a pre-order traversal. So the pre-order going to be the root. Now let's just define two functions. So the pre-order, I'm gonna define a boolean of pre-order. So inside it's gonna be the node. Yeah. And I also needed to define another function. I'm gonna call it depth. So it's gonna be an integer of depth. So I'm gonna call it maximum of depth. So inside I'm gonna give a tree node. Yeah. So let's just write those two functions. I think those two functions are gonna be easier if we know how to traverse a tree, how to calculate the depth. If node equal to none, we can return a 0 immediately. Otherwise, we're gonna check the maximum. Yeah. So max dot maximum of the max depth with the left, and max depth with the right plus 1. So this is for calculating the maximum depth of the tree. And here we just need to finish the pre-order traversal. So if node equal to none, we're gonna return a true. If node not equal to none, yeah, and we're gonna use math.absolute. So this means the node is not equal to, definitely the node is not equal to none. Yeah, if it is not equal to none, we're gonna check the absolute value of the depth for the left and the right side. Yeah. So the maximum of depth at the left side minus the maximum depth of the left side minus the right side. Yeah. If the result is more than 1, we're gonna return a false. So otherwise, we're gonna call the recursive function. It's gonna be the pre-order node dot left and pre-order node dot right until we find it may be a false. If we didn't find the false, so we're gonna return a true. Now let me just run it to check if everything's okay. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works and it's pretty fast. The time complexity is O(n) squared. So n is like 5 times 10 to the power of 3, so this is okay. If this number is too big, we have to solve it in O(n) time complexity. Then it's going to be a little bit difficult. But up to now, I think this is still okay for solving the unbalanced binary tree by using the O(n) squared time complexity. I think that's all about it. Thanks for watching. See you next time.